Friends, today I am going to discuss compressibility effect. Okay, so compressibility effect. This will be our last fluid properties. Okay, so compression means decreasing the volume, and it is directly associated with bulk modulus. Okay, bulk modulus K, and it is the measurement of elasticity. Elasticity, you know, if you apply the force, then it will elongate and it will go for deformation and up to elastic limit, and if you remove the force, it will come to the original position. That is called measurement of elasticity, compressibility. Okay, so bulk modulus. Now another aspect is this one, that is if it is related with the density also. It is related with the density. See, now that means if we apply the pressure, okay, apply the pressure, then it will change the shape. So change in volume, there will be change in volume if pressure applied. If pressure applied, okay. So if you apply the pressure, then change the, it will like this. See, so pressure is applied from both sides, then this shape will change, okay, like that. Okay, so change in volume if pressure is applied. So now here change in pressure, let us call it as dP. So dP is directly proportional to its volumetric strain, or we can call it as change in pressure. Change in pressure is inversely proportional to its volume. Okay, here we can call it as like this. Change in pressure is directly proportional to change in pressure is directly proportional to change in volume. Or we can call it as volumetric strain. Okay, or we can call it as change in pressure is inversely proportional to its volume. So that pressure and volume are opposite. See here, change in volume if pressure applied. So pressure increases, volume will decreases, like this. Okay, so that is the relation. Now this is dP. From this equation, proportionality constant will come dk minus dV by V. Why minus? See, this minus means if we apply the force, what will happen? See there, change in volume decreases, so volume reduces. That is why minus dV by V. Therefore K is equal to dP by dV by V. That is, we can call it as direct stress, or we can call it as pressure. Both are having same unit. So, okay, by this is volumetric strain. So stress by strain is constant, and that constant is called, K is called bulk modulus. Okay, so see, though the topic is compressibility means related with the volume. Okay, so and it is associated with bulk modulus that I have given. Bulk, it is associated with bulk modulus. It is the measurement of elasticity. Okay, elasticity means compressibility, decreasing the volume, and it is dependent upon the density also, that I am going to discuss now. Change in volume if pressure is applied. See in the figure, if we apply the pressure, then there will be changes in volume. Okay, so we can call it a change in pressure. Change in pressure is inversely proportional to its volume. Change in pressure is changes in directly proportional to change in volume. That is, here we can call it as, this is nothing but dV by V. Okay, sir, volumetric strength. So change in pressure is inversely proportional to its volume. Okay, so like that. That proportionality constant is bulk modulus, and why this minus? When we apply the pressure, then volume will reduce. That's why minus dV by V. And this K is constant, and this will be dP by minus dV by V. Okay, so that is dP is nothing but direct stress or direct pressure by dV by V volumetric strain. So stress by strain is also a constant, and that is called bulk modulus. Now I was talking about the density. See now, during the flow, if density does not change, that means there is no change in density. See, density, I am talking about the mass density. So it is nothing but mass per unit volume. Okay, so during the flow, if density, this is mass density, I am talking about the mass density. Okay, so during the flow, if density does not change, then the flow is called incompressible flow or incompressible fluid. During the flow, if the materials, that is fluids, density does not change, if it changes also, that may be very minor amount only, very little amount, that is negligible, then the flow is called incompressible flow, or fluid is called incompressible fluid. Incompressible fluid. Okay. On the other hand, if density changes, see, that's why I had written here, it depends upon the density. So if the density changes, then that means mass per unit volume changes. See, then if density changes, then the fluid is called compressible fluid or compressible fluid. For example, we can take almost all the liquids are incompressible because their density does not change. It depends upon the density here, see. So liquids mostly incompressible, and gases are compressible because their density are changeable. Okay, that's why we can call it as all the liquids are incompressible and gases are compressible. Okay.